Lesson 60. Turning over the odometer into the 60s. This is a geometry lesson. It's focusing on solids. And by solids, what we mean is three-dimensional objects, things that have weight and shape and size. And we're also going to talk specifically about prisms and cylinders. So by all means, grab your pencils, take your notes, follow along with me. I'm on page 242 in the book, and because this lesson has a lot of pictures and labels and descriptions that I'm not going to cover, I want you to spend some time looking through the instructional part of this lesson together. I'm just going to show it to you now. You'll see there's lots of pictures describing the different shapes. And again, notice they're all three-dimensional. Notice that they all say either right or regular. That means that they either are built using right angles, or like this one's a regular square pyramid. That means all four sides are the same. So these are very precise, even, balanced looking structures. I want you to notice that the lateral edge means the side of the object. Lateral means side, I think in Latin. And so here are a bunch more. These are prisms, and this is when you have an interesting shape at the bottom, a triangle, a rectangle, a trapezoid, a pentagon, and then the sides just go straight up and it becomes a three-dimensional object. So take some time to look through this, make sure you understand it. You guys could read through it together. And we're going to talk specifically about the volume of prisms and cylinders. So let me switch back to my notes here. And this is pretty cool because it's not a complicated formula or idea. Look at that, I left a little space for the missing D. When you're trying to find the volume of a prism or a cylinder, the first thing you do is you calculate the area of the base, which is something you guys already know how to do. We've calculated the area of the base of funky objects, and then you multiply it by the height. So there's a formula that you can put in your list of important formulas, and let's just take a look at how this works in a problem. Example 60.1. The area of the base, let me show you the picture. This is what they call a right pentagonal prism, meaning, see, there's a pentagon at the bottom, 5 sides, and the sides go straight up on the top. The area of the base, they're telling us right straight off, is 28 centimeters squared, and the length of the edge is 10 centimeters. Okay, so let's look at that here. So the area of the base, they're just telling us, is 28 centimeters squared, and then they're telling us the length of the lateral edge is 10 centimeters. Well, the length of the lateral edge is the same thing as the height. That's just the length of the lateral edge is just a fancy way of saying that line right there. And that is also the height. So, all we have to do is multiply. And look at what a pal John is. He gave us 10, so we don't even have to stress over multiplication. And notice that this will be centimeters cubed. We know that, first of all, because we're calculating a volume. Volumes are three-dimensional. I told you that right up here. So when we know that three-dimensional objects are always cubed. But we can also figure it out because here we multiplied a squared number by a power to the 1 number, and we add those to know that that's cubed. So this is a very simple process. It sounds super complicated, ooh, scary, volumes of prisms and cylinders, but using this formula, it's super easy. So, check, let me just do this. Check on that one. And we've talked about prisms and cylinders, we talked about volumes, so now what we want to talk about is the other style of problem, which is example, this was a volume problem. Example 60.2 is called a lateral surface area. problem, and these are cool. I have a visual effect to show you. The idea of a lateral surface area problem is that you imagine a geometric shape like this. Yeah, that's a pentagon. Pretend it meets perfectly at the top. I have a pentagon shape at the base of my structure. There it is there. But I've also got tall sides. And in this problem, they're not asking us to find out the area of the top or the area of the bottom. They don't care about the volume. They just want to know how big is it, what's the area of these sides. So what you imagine is what I've got right here. Imagine that you can just open up the sides. Notice there are 1, 2, 3, 4 facets. It's kind of like 5 separate rectangles because those are the sections that were formed by the pentagon. So if you can visually imagine taking these pictures in the book and opening them up, you can even get your very own cardstock like I did. It's kind of a low-tech visual effect. But you can use this as a model for setting up the problem. So in this example, the lateral surface area of the right prism, just a second, never mind. Find the lateral surface area of this right prism whose bases are regular pentagons. Okay, that sounds confusing again, but let's just draw a funky little pentagon. It doesn't have to be perfect, just 5 sides. Now we imagine the sides all going up. Pretend it's perfect and even. It's not, but just, pretend. And now we're going to pretend that that's even. Look, it looks really crumply bumpily, doesn't it? But pretend it's perfect. Just work with me here. Okay? And what we're going to do now is put in the labels. We know that each of these little sides along the bottom, each one of those is 8. And we know that the top, that tall edge, is 15. And they tell us that the units are in meters, but it doesn't really matter. So what we do is we visually imagine opening this model up just like we did my piece of paper. And it would be exactly like this. It would have 5 sections. I'm not going to be able to make these perfect. See, these approximate my fold lines. Just like along here, there's 4 fold lines, so there's 5 perfect sections. And we know that the edge of each one of these is 8. We know there are 5 because it's a pentagon. We know they're all the same because it's a regular pentagon. So we can make all those assumptions. And then the other thing we need to know is how long is this side. And it tells us right here. This edge, which matches to this edge, is 15. So now we need to find the area of this piece of paper, just as we've laid it out here, and we know the area of a rectangle is always equal to the length times the width. We've known that for a long time. So we just, and length times width, I always get confused, which is which, it doesn't even matter. But we just need to add all these up. 8, 1, 2, 3, 4, 5 eighths, so that means there's 40. Let's call that the length, times the 15, let's call that the width. And let's multiply. And let's just do that over here. 15 times 40. I'm going to put down the 0. 4 times 5 is 20. 600. And we need to put a unit on it. They told us it was meters. And now that we've multiplied 15 meters by 40 meters, we have meters squared. So the lateral surface area of this rectangular prism, this right prism with a pentagon base, is 600 meters squared. That's the area of this. Okay? So we've done all the examples in the chapter. We've covered both of those. So what I would like you guys to do in whatever time remains in class today is to do the practice problems together. Do at least A, which is it's a volume. And if you have time, I would love for you to do B, which is lateral surface area. You need to make sure you have the answers. Remember, lateral surface is the piece of paper. Okay? Whoops. And you'll have the answer to A in the back of your book. See if you can track down a mom or somebody who's got the full set of answers so that you can do B as well. And follow along with these examples and see if you can make it work. Good luck.